our universe might not have a start. For quite a long time, we had faith in the hypothesis of the enormous detonation. However, presently, genuine observations of the early universe show us something totally different. Behind the Pandora universe cluster, the James Webb Telescope has found a secretive structure so old and so huge that it would never have existed in a youthful universe. This gives us additional proof that our speculations about the Big Bang and the age of the universe are off base. There may never have been a beginning. The idea that something could have no start and no end creates some issues for a considerable lot of us. We are accustomed to thinking in spatial aspects where things and cycles have a start and an end, or limits. Scientists also struggle with infinity since it presents unsolvable mathematical problems. Scientists can only work out quantities of length, width, and height within a fabricated space. If our universe is truly infinite, then it has no length, no width, and negative length, in fact. However, most of our current theories about the beginning and evolution of the universe rely on calculations that assume space is closed in some way. Since the James Webb Space Telescope has given us increasingly more proof that the past explanation of the development of the universe is incorrect, different hypotheses are becoming more likely. Toward the dawn of mankind, galaxies gave the impression that they were already billions of years old. These early galaxies should have shown signs of a beginning phase of development. Specialists also expected to see, at last, the incredibly bright stars of the first age through James Webb, but here too, there has been no sign so far. All we see are structures that look so old that the Big Bang could never have occurred 13.8 billion years ago. What is behind the Pandora group? In February 2023, NASA published another deep image from James Webb. Here, we see the Pandora group, otherwise known as Able 2744, with the early consolidation of 3 massive galaxy clusters. This extraordinary discovery was made possible by Webb's NIRCam. Webb observed the individual areas of the group for as long as 6 hours and then perfectly gathered the new deep image from 5 individual pictures. The image shows around 50,000 light sources, the oldest of which are expected to reveal further secrets of the early universe. There is more to this picture than just another brilliant idea of our telescope technology. The gigantic group acts as an extraordinary gravitational lens, amplifying all objects behind it. Due to the arch of spacetime, the ultra-deep near-infrared camera observations before the APO of reionization program, or REVEAL for short, are responsible for this image. Scientists examined every hint of light in the picture and noticed once again something that calls our standard models of cosmology into question. Behind the group, a structure became noticeable that is so large and monstrous that it's contradictory to our previous explanatory models of the early universe. REVEAL has set itself the goal of capturing the first light signal from the APO of reionization. Around this time, the universe is said to have been mostly dark. However, the image once again shows that some of the light sources are likely galaxies that are over 13 billion years old, which again means that they are very old for our explanations. This image adds to the crisis of astronomy with the baffling structure. Preliminary measurements showed a redshift value of z equals 7.9, meaning the object was already present around 650 million years after the Big Bang. How could massive galaxy clusters have already formed 650 million years after the Big Bang if at that time there were, as we thought, mostly isolated first stars or protogalaxies? Once again, so the old hypotheses are being tested, and this discovery increases the likelihood of a much older or boundless universe. The photometric NIRCam data from the image has now been made available to many global research teams, and astronomers around the world are now working together to uncover the truth. What if the Big Bang never happened? It's exciting. We are currently facing more possibilities in cosmology than we have for quite a while. Before the telescope was launched, scientists were actually expecting the long-awaited confirmation of their hypotheses. But now, entirely new scientific aspects are opening up, and we will experience changes. What could this mean now? We may soon be able to look much further back in time. And if we still can't find any indications of an early universe 14 billion light-years away, we will at least know for sure that our universe must be much older than previously expected. This would not yet be evidence of infinity, but this possibility would become more probable. Again, we should investigate what supports this. The uniform distribution of the cosmic microwave background radiation across the entire sky shows that the universe is homogeneous and isotropic on a large scale. Both can be interpreted as a sign of a vastly expanded universe. The Hubble Space Telescope, moreover, showed us that the universe has a flat geometry. Some researchers also interpreted this as a potential sign that our universe is endlessly extended this way, and that there is another reality that we should not ignore. While considering the subject of the infinity of our universe, no one has yet found an end to the previously known universe. We observe more than 90 billion light-years, but there is no proof of an end. Ideas about the edges of the universe have so far been pure scientific thought experiments, but not proven facts. James Webb's discoveries now show that there is no start on the timeline either, demonstrating that an infinite universe will be difficult to prove. Even the best telescope can never show infinity. Regardless of whether we one day travel through space in spaceships, we could never know for sure if it has an end, until we find it. What might an endless universe mean? It sounds intriguing to live in a universe that goes on forever, has no beginning and no end, and has always been there. But our science has problems with this idea. There are the previously mentioned issues of describing such a universe scientifically and precisely. Infinity would mean that we are probably not going to succeed in doing just that. We can explore finite regions and make estimated predictions as to which powers are working there and where do they come from. However, the sum of the boundless universe would most likely evade numerical and logical perception. Who says that we need to quantify and deductively make sense of each and every edge of the sublime universe? We need to inquire ourselves why we are so carefully looking for this data and comprehension of the universe. It's because we are searching for answers about our own beginnings. Where did everything come from? Who made it and what is it doing here? Innate science attempts to make sense of these inquiries with equations and computations. However, it is now arriving at its cutoff points. Anyway, liberal researchers also see the new discoveries as a chance to learn more about the universe in a totally new way. The discoveries might empower us to arrive at new levels with our exploration. So far, we need to concede that, notwithstanding numerous speculations and telescopes like James Webb, we still have close to zero familiarity with the universe. The endlessness of the universe could also imply that we are in a sort of time-space circle or in a very well-made holographic projection. This would mean that we need to advance our consciousness and brains to grasp the real essence of the universe. Might we at any point get to the truth with a quantum computer? Now, we come to an intriguing part in the investigation of the universe that could really be a transformation. Quantum computers may, before long, be so powerful and insightful that they will give us answers to all the inquiries without us searching for long. These entrancing machines use the principles of quantum mechanics to process immense amounts of data or perform complex computations. Quantum computers use qubits, which, unlike the bits of classical computers, can not only assume the states 0 or 1 but also superposition places of these states. As you might know, quanta consolidate all potential outcomes and only interpret a certain structure when they are measured. This conduct shows that quanta, hypothetically, contain all the potential outcomes of the information of this universe. We just need to figure out how to decipher the code of quantum language and program the technology so that it furnishes us with answers that go the distance beyond observational possibilities and classical numerical estimations. We should accept the issue of the contrariness of Einsteinian physics with quantum mechanics. So far, only string theory exists that can close the gap between the two, but we can't prove string theory since it includes undetectable aspects. There are now endless variations of string theory, and not a single one of them quite fits. A quantum computer can accommodate this information and show us our mistakes in an exceptional way, and the computer could replace existing gaps and misinterpretations with reasonable estimations. We could even have the option to combine quantum computers with artificial intelligence, and then we would probably have access to nearly infinite data. Telescopes would then be another fun way for us to observe the beauty of the universe, but we would no longer need to piece meticulously together what we see into a grandiose puzzle. Scientists predict that even the most straightforward variations of quantum computers will actually be able to show us whether dark matter truly exists. Up until now, we have used the presumption of dark matter to explain anomalies in the development of galaxies, but its presence has never been proven. The quantum computer could furnish us with many types of explanations for the peculiarities that we have so far explained with dark matter, and also show us whether the concept of dark matter is real or a mistake. The first models of these computers are already being used at the moment. The designers are still having issues with the responsiveness of these cutting-edge machines. Quantum computers are incredibly sensitive to vibrations and are only operated in extraordinarily fixed and protected rooms. Cooling presents a further challenge, fundamentally. Anyway, these processes are just a further advancement of the massive computers that existed during the 1960s and 70s. Today, we have little workstations and cell phones. People who worked the first massive computers would never have imagined that in those days. By and by, it just required years and years for computer technology to progress to where it can be seen in almost every household today. Subscribe now and anticipate forthcoming video hits.